starting Monday, we are gonna start waiting outside because I need to make sure that as you guys enter, you are leaving your backpacks outside. I will remind you what you need that day, whether it's your notes, your Chromebook, whatever it is, and we will all come in together. Also, it will help us make sure we know who is tardy and who is not. So starting Monday, get ready, be lined up on the ramp, ready to come in. Let us let you in, please. We are going to go over page 18 in notes. Another point of frustration, you have a test on Monday, but it seems like one person finished the homework. I tried to help you by sending you a remind where number 2 and part of number 3 were completed for you. That was your sample. But I still see people who didn't even have that done. And then to complete the rest. I don't have a remind. Well, that's the code. Yeah, you don't have to download the app. I don't think you have to download.
You just put in that code.
You just test. Maybe I'm sure. If you don't have the remind, you're gonna text the message to 81010, and you're gonna put in the message at Biotech. So this is like the person that you're texting, and this is your message. Yes, you put the app, and then it will text you back and say reply with your full birth date. It needs to confirm that you're like 13 or older. And then that's it. All right, so I don't have a way to show the answers on the Zoom recording, but if you're watching the Zoom recording, I will send you the answers through Remind. Okay. So I was hoping to go through this more quickly because you guys should have had it partially done, but we're going to have to go through it more slowly. Okay. So we're going to go over page 18. We need to finish our notes if we have time. I've decided that we are going to collect your lab notebook on Tuesday. You may have time over the weekend if you take your lab notebook home, if your 3 labs aren't done or something's not done, or Monday after the test, you have things you need to glue in or things you need to complete. But we are going to be collecting your lab notebooks Tuesday. That's a big deal because we are grading how many labs? Cheese, concentration, volumes. Yes, we are grading 5 labs. That's 5 assessments that are about to go in your grade book. So if you need to take your lab notebook home this weekend and make sure it's perfect, let's do that. And then your test on Monday. Let's go over page 18. I know you guys just learned this yesterday, so let's take some time to practice here. Okay. I will post this, even though you're going to fill it out right now. I am going to post this because my color coding could be helpful for you. So, number 2, we want to start with our equation. Angel, what's our equation? Okay. And let's see, Mauricio, what does the C stand for in our equation here? For like just in our equation, what does C stand for? Something about the solution. But C literally stands for stock solution. What? Starts with a C. Concentration. Good. Concentration of our stock solution. Okay, good. So C2 is our desired concentration, what we want. Okay, and Princess. Tessa, what does V stand for in this equation? Something we measure, starts with a V. volume. So this is our volume. Usually this is what we are solving for. We need to know how much of the stock do we use. And V2 is the desired total volume we want. Okay, so given this equation, and we have this question, we want 10 milliliters of 0.5 molar copper sulfate from 10 molar copper sulfate. Give you a second to think, what is our C1, C2, and V2 going to be based on that question? I'll be calling on a lot of cards today, so remember, make sure you don't shout out somebody else's answer. And if I give you guys a minute to think about it, you can talk at your table groups. Do you want to be table groups? Okay. All right. Christina, what is our C1 for this equation, for this problem? 10M. Good. 10 molar. Remember to always put your units. Oh, what is this? Thank you. Sweetie. 10 molar times, and we are solving for V1. So 10 molar times V1 equals. What is our C2? 0.5 M. Very good. 0.5 molar. That is the concentration we want because we are diluting it, right? We are going from a 10 molar to a 0.5 molar. Times. Miranda? Esme? Aisha? What is our V2? What is the volume we want? 10 what? 10 milliliters. Okay. You said it. Okay, Ethan, what do we do now? We have our equation filled in. We eventually want to cross out our molars, but first we have to do what? Order of operations. Yes, first we need to multiply. So have your calculators out. We have 10 molar times V1 equals, what's 0.5 times 10? Half of 10 is, very good. 5 molar times milliliter. Okay, we keep our units for now. Okay, go ahead and write that down.
Milliliters, 5 milliliters times them.
It wouldn't matter. You can flip flop your units. Eventually, this is going to cancel out anyways. Okay, what's our next step? Amy. Remember, we're solving for this. We want to get V1 by itself. Divide by 10M. Good. Both sides. Important that you show the canceling of your units. So we're canceling 3 things here. Good job. What are we canceling? The 10s, the M's, and the M's. Very good. Ooh, just made our equation look a lot cleaner. So now we just have V1 left on the left side, which is good. That's what we're solving for. Equals what? 5 divided by 10? 0.5 milliliters. Answer. Okay. What does this mean? What does this mean? This means the technician is going to use what?
0.5 milliliters of stock solution and add 9.5 milliliters of the
Of stock solution. If you want to write solution shorter, you can do SLTN period. That would be solution. You want to use an abbreviation. And add. How did you get 9.5 milliliters? Very good. You don't have to write this in your description, but I'm going to put it here just in case you're not sure how we got it. 9.5 milliliters because we wanted a total of 10. So if we want a total of 10, but we've already used 0.5, that's how we get our 9.5. So we have our 0.5, we add 9.5 to that to get our total of 10. Okay. The next question, I want you guys to work at your tables for how long do we need to do a question?
2 seconds.
Let's do 2 minutes for the first one. Working on that is not going to be good for you. Except for you have 2 different units.
Volume.
This next one is tricky. Let me put on the board. You might want to all write this on the bottom of your notes. As I was doing these problems, I thought to myself, they might want a checklist, a step, 3 steps to always use on these problems. First step, which you're going to have to do in this question. You might want to write this down. If you memorize this, it can help you on a test. First step, do units match? I just have this at the bottom of the paper. Do the units match? If not, convert. In number 3, do we have matching units? No. So we're going to need to convert. Second step, plug into the equation. Third step, solve for your variable.
So in the event that we have to convert, you want us to go on from, like, let's say to milligrams or to grams?
You could do it either way.
So whatever the answer is?
Well, yeah, if it says I want something in milliliters, then you should convert to milliliters. If it does not specify, you could give your answers in liters or milliliters, it doesn't matter. So you could convert either way. For number 3, I'm going to convert my liters to milliliters if you want to follow along with what I'm going to do. Okay, so go ahead. Work together. We're going to do 2 minutes on this first one. You have 2 minutes to get your answer.
And 1 gram is like 100,000.
Does everybody have the 3 steps?
Yeah.
This one is actually the hardest one. You have to double convert. I won't give you a double convert on your test. Because you're in a college class. Well, you're in a college class. Cover your noses. Okay. I actually have your conversions up there if you want to have that help you get started. Okay. You have 30 seconds to be ready to get called on to help me work out this problem. We're having conversations that are not on topic, and you have a test Monday. So let's not get off topic, please. Okay, first step, number one, we need to convert. We need to make our units match. So I decided, since we have milligrams per milliliters, we don't want to have liters in milliliters. Those don't match. So I decided to make my liters into milliliters. So 2 liters is 2,000 milliliters. Okay. We also have the unit of a gram per milliliter. We have milligrams and grams. Those don't match. So we need to convert. 1 gram is 1,000 milligrams. Okay. Now that we have our conversion set up, Xander, C1. What is C1? Good. 1,000 milligrams per milliliter. Yes. I'll show you why. Okay, equals. What is the desired concentration, Jay? C2. So the concentration we're starting with is 1,000 milligrams per milliliter. What are we wanting? 5 milligrams per milliliter times, what's our desired volume? Alan, what's our desired volume? V2. It's one of those 3 colors. You have it on your paper. Where's your notes? No, our volume? Desired volume. 2.
What? 2 liters.
2 liters, but we converted that to 2,000 milliliters. Because that's the volume we want. It says we want. Guys, I'm not moving the test. So all of this extra talking, I understand some of it's on topic. I get that. But there's some that's not. We want 2 liters, so that's our desired volume, but we converted it to 2,000 milliliters. Okay, next step, help me out with this. What do I do next, John? Okay, where? Are you confused in how I plugged in these numbers? Okay, so in the question, it's saying, well, were you confused on number 2? Okay.
These are non-intellectual.
So stop. Don't even. All these side comments. What, we just wasted 10 seconds. Don't even. That's not cool. The whole point of what we're doing right now is we're making dilutions. So in a lab somewhere, we have a stock solution, and this usually is more concentrated. So in this case, our stock solution is 1 gram per milliliter, okay? What we want to use in a lab is going to be more diluted than that. So we want to use our stock solution to make a dilution. You're diluting it, right? Yes, so you make it more watery, right? Okay, so our dilution, it says we want 5 milligrams per milliliters. Sorry, there should be 1,000. Because your standard says that you should be able to prepare these. So if our stock solution is 1,000, but we only want a 5 gram per milliliter. So in order to get that, I take a certain amount of this stock, okay? I take a certain volume and I put it into my dilution, okay? And then I add water to dilute it. So I use some of my stock and then I add a bunch of water so it's diluted. So that's what we're doing. We need to figure out how much of the stock do I use to get the situation that I want. Okay. Huh? So if you are in a chem lab and I say, please prepare me a 5 gram per milliliter, please prepare me 2 liters of 5 milligram per milliliter from our stock solution, you would know how to calculate and do that. They do in a lab. My first teaching job. Okay, so this is my concern. You guys don't want to be biotechnicians, fine, but that's what this class is preparing you to do. You're in this class for whatever reason you're in this class. So yeah, kind of. I mean, I do want to make sure you understand what you're doing, but if you're like, when would I ever do this? You may not be a technician. You may not be a chemist. So you may not use this in your actual life, but you're in this class right now. And so that's what you're learning. Okay. So that's what we're learning how to do. We're learning how to make these dilutions. So we take the equation, plug in. On your test, this is what you're going to have to do. Okay, so let's keep practicing. And hopefully by the end of the worksheet, it'll be making a little more sense. Nope. We should, but we don't have all the time. Okay. So now that we have this filled in, math-wise, what's the next piece of math we should do? 5 times 2,000. First, we have to multiply, and then we divide. Okay, so we have 1,000 milligrams per milliliter. If you want to show all your work, yeah. What's 2,000 times 5? 10,000 milligrams per milliliter times milliliter. Now, you might be wanting to cancel out those milliliters, but don't, okay? It'll be easier if you don't. Okay. What do we do next? We divide what by what?
1,000 by 10,000.
So we want to isolate this number. Okay, if I did 5x equals 20, what will we do?
Divide 5 from both sides.
Divide 5 by, yes, divide both sides by 5 is how I would say. Okay.
It's the same thing.
It does make a difference.
No, it doesn't.
Okay, so we divide 1,000 milligrams per milliliters and divide 1,000 milligram per milliliter. At this point, we have canceling to do. What's my first 2 things that cancel? Milligram per milliliter and our thousands. So good, we have successfully isolated our V1 and our units milligrams per milliliters. Good. Now we can cross off 2, 3. So our answer is 10 milliliters. In a lot of cases, like really you could, if you wanted to convert all your milliliters to liters. Right, yes, because if I asked you, if we converted this to liters, how many liters would it be? 0.01, right? So if I said, measure me out 0.01 liters, in order to do that, you would probably convert it to milliliters anyway. Because if you think about a graduated cylinder, it doesn't have 0.1 liters on it, right? Most of your measuring instruments are in milliliters. So yeah, that's why I usually like to go to milliliters. Yes.
Put it all in liters.
Then if you got 0.01 liters,
It was all correct.
Yeah.
It was all liters.
that's fine. As long as it converts correctly, you're fine. Okay, so now that we have our answer, Edgar, help me fill in this sentence. We're going to use how much stock solution? 10 milliliters of stock solution and add well, we wanted 2 liters, but we converted that to 2,000. So if our total solution needs to be 2,000, how much do we add? 2,000 minus 10. What is that? 1990 milliliters. Very good. Okay. All right. Here is number 3. You're filling in number 3.
Water?
Yes.
How come yesterday you put of
Deionized. I'm making it shorter for you. You want to write deionized water? That would be more correct.
I did it.
So as you guys, I know some of you are taking pictures now, which is fine. I will send this out. The highlighting really could help you guys. Okay, if you notice the trend, I'm highlighting. At the top, it says I'm highlighting my C1s in yellow, my V1s in blue, my C2s in pink, and my V2s in green. So you might be able to find a helpful pattern based on the highlighting. That's another unit, so it's like 10 times. So 10x is going to be 10 times more concentrated than a 1x. Just think of it as a unit. Yes. Good. All right, this next one should be easier. You don't have to convert anything. You can start with step number 2 and do step number 3. I'm going to give you another 2 minutes on this one. If you feel like you're understanding this at any level, you should hopefully be explaining it to the people around you. 2 minutes. What? The conversion. This one you don't have to. On your test, I will double check. You will definitely not have to do a double conversion. I might have put a single conversion. X is just times. Like 10 times stronger. Just think of it as a unit. We'll cancel it just like we canceled MG. Just think of it as a unit. Just think of it as, you know how we have molar? Think of it as a unit. Yes.
Like you, buddy.
Oh, well, the repests are gone. The repests are gone.
Yeah, it's just legs.
I think I got that.
Yeah, in our last period, I'll
Get it?
That was Anna.
Yo, Elisha,
Yeah. 10 seconds.
Why'd you answer?
Okay, you guys, whatever is happening here. That whatever conversation is happening needs to happen outside. Emily, I want to know, what is our C1 in this case? What is the concentration of our stock solution? 25x, very good. Remember, our concentrated solution, our stock solution will always be higher than our dilution.
So, wait, I don't understand.
That's to get your how much you add. So basically, for here, you would do your V2 minus V1. Okay, good. 25x times V1 equals, what is the concentration we want, Chrislyn?
Oh, would it be 9?
We're starting with 25x, but we want to dilute that to what? Number 4. 1x. 1x, and what's our desired volume? Emma? Jocelyn? Our desired volume. How many milliliters do we want? Good. 950 milliliters. Okay. What's the first mathematical step we should do here, Tessa? Okay, I'm glad you're in agreement. So we're multiplying 1 and 950. So we have 25x times V1 equals, that's easy, 950 x times milliliter. You could do milliliter times x, it doesn't matter. Remember, multiplication is, what is that called when you can flip flop it? There's a name for that, I forget. Yes. One of the properties.
Inverse, yeah.
Yeah, okay. Our next thing that we should do, Jocelyn. You just solve for this, right? Yes, divide by 25x, very good. Both sides. Okay, and we have 3 things cancel. Our 25s cancel, our x's cancel, and our x's cancel. So now we just need to do 950 divided by 25. Did anybody do that math?
Yeah, woo, 38.
Oh, very good. 38 milliliters. So our V1 equals 38 milliliters. Okay, good.
What does it mean when there's 2 atoms?
Milli. So it's little big, millimolar. So you're going to want to convert that to molar. So it's like going from milligrams to grams.
Molar is.
You have milli to base. Molar is not on the conversion chart. Yeah. All right. Sammy, no. Mauricio, fill in the sentence. We're going to use how much? 912. Very good. We got 912 because we took 950, which was our V2. That's how much total volume we want. But we already used 38. So we had to do 950 minus 38. Thank you. All right. 2 minutes on the next one. The next one, let's see. This one is a single conversion. You have to single convert. I always suggest going liters to milliliters.
Calculator.
Liters to milliliters. Let's see if I have a double conversion or a conversion.
Is it 0.005 is 5?
Okay, I have news. For your test, maybe you want to put a star next to this one. It will be most like number 1. It'll be most like number 1. No conversions necessary. Okay. So you won't have to do step number 1, basically. You do have number 36, which is your extra credit kind of style question. That is a single conversion. So 36 would be similar to number 3. Huh? Yes, it's a multiple choice test. Yes. Nope, sorry. Okay. You have 30 seconds to get ready to go over this question. I already gave you your conversion. That should make it easier.
I think I got it.
Good. That's kind of the plan. By the time you're done with all the practice, we should be getting it a little bit better.
I got that too.
Oh, all right. Angel, what is our C1?
5 moles.
5 moles or molar, okay? Good. That's the solution that we are starting with. We are starting with a 5 molar solution.
Can I do the whole problem?
No, I really want to. Sorry. Christina, what is C2? Very good, 0.2 M. And B2, John? The volume we are desiring would be 5 liters. You could leave it as 5 liters. But you could also convert. That's fine. Well, who did milliliters? Raise your hand if you did milliliters. Okay, raise your hand if you did liters. It seems to be half and half, so we'll just leave it as liters for this one. For this one, remember, step 1, do our units match? We have M and M, those match. L is by itself, so you can leave it, it's fine. Okay, what is the first math step we should do? Jocelyn, M, what should we do first here? We have it all plugged in. What mathematical step do we need to do first? Am I going to multiply the right side or divide something first? Well, multiply. First, we want to multiply the right side. Because, I mean, we could divide by 5m, but then you'd be doing 0.2 divided by 5 and 5 divided by 5. I think it's easier to just combine these two terms and then divide. 5m times b1 equals, what's 5 times 0.2? Who did this math? 5 times 0.2? 1,000? Did you do 5,000 times 0.2? So what's 1? 1 mole times liter, okay? So, okay, so it could be, you did milliliters, you would have 5m times b1 equals. So you said if it was 5,000 times 0.2, it'd be 1,000, right? So you could do it this way. That's fine. Okay. What do we do next? Tessa, what do we do next? Divide by 5m, very good. And we have some things cancel. What do we have canceling, Jocelyn? 5 and m and m, very good. So we are left with b1 equals 1 divided by 5. 0.2 liters?
Yeah, or 200 milliliters.
Or if you did it this way, you would get 200 milliliters.
I did it both ways by accident.
That's fine. On a test, it will specify if I want it in liters or milliliters. Okay. So this means, Emma, help me fill in our sentence here. How much stock solution are we using? Okay, 200 milliliters, we'll go with that, or 0.2 liters. Or 0.2 liters. And add how much of water? Okay, so if we are, yeah, so B2 would be 5 liters, so 5,000 milliliters. Minus how much we use, which is 200 milliliters. Yeah, so it should be 4,800. Or if we did liters, it would be 5 minus 0.2, which would be 4.8 liters. 5 minus 0.2. All right, we have one more. How many more do we have? 2 more. All right, we're going on number 6. This one is a good candidate for something you'd see on the test. Is a no conversion. It's similar. Yeah, you have one no conversions and one with a single conversion. Number 7. This is millimolar. So you're going to want to convert millimolar to molar. So this is, yeah. So it's like going from milliliter to milliliter.
Multiplication.
Yes.
Uh-huh. Yep. 250. And then X times ML.
Oh.
Yep. 150. Yep. This is like how you know.
Add the math.
0.5 times 5. Looks like you said, anybody else need a stamp for this page? Oh, I didn't start your timer. Bummer. Hello. If you're talking to me, I can't hear you. Water? Oh, you can sit at this end table. Sorry. Is it raining outside? Oh.
We're literally out there 5 minutes ago.
Nose. All right. Yeah, if you really need to. But we're going over this question without you. I said they can get their backpack as it's raining. All these markers are dying. We need to get some new ones over. I know. They're just not aware yet.
Oh, yeah.
All right. Tell Kristen I'm waiting for her.
Is it raining hard?
You get it? Ding, ding, ding. Okay, good. Yep. All right, Kristen's not in here. Somebody please give me C1 for number 6. Oh, there you are. 50.
You said we didn't have to convert.
You didn't.
V1.
Times V1. Thank you, Tessa. Equals 2.5x. Times 100 milliliters. Good. Jocelyn, what's our next step? Yes. Very good. We're going over this. You should be seated. Good. So we're going to multiply 2.5 times 100, which is? Thank you. 250x times ml. All right, Kristen, you're back now. What do I do next? Slide. 50x both sides. Okay. I have 50 canceling, x canceling, x canceling. So I'm left with V1 equals 5 milliliters. Wonderful.
If we don't put B1 equals, would that be considered wrong?
Well, your test is multiple choice.
Oh, yeah. I know.
However, I am going to use scratch piece of paper and I would need you to show your work. So in your work, yes, you should put it, but in your answer choice, you have multiple choice. All right, Annalie, help me fill out the sentence. We are going to use how much stock solution?
What if your water breaks?
Huh? 5 milliliters of stock solution and add how much water? 95. Please tell me, Edgar, do you agree with 95 here? Okay, good. How did I get 95? $100 minus 5. So remember, it's always going to be your V2, how much your total volume is, minus how much stock you used, which was 5. Sorry about that.
Do you think during the weekend you can post some practice questions?
So I started a review presentation. I will show you how much more time we have. A couple minutes. 10 minutes?
Yeah.
8 minutes.
Oh,
I'll show you what it looks like. I will complete it and then I will put answers in there. So yes, it won't be in quizzes form, but I will have a document to help you go through these. Yes. Your homework is, yeah, make your lab notebook look nice, if it's not already nice, and study for your test. Yeah, page 16 we are supposed to get to. Page 16 is just like the review worksheet number 2. So we're supposed to do that today. Yeah, we won't be able to do that in 8 minutes. How about I'll do this. I'll fill out a page 18 in my own handwriting and I'll send it through Remind. Okay. So if you don't have Remind, you guys really are missing out on stuff. Page 16.
I just don't know how it works.
All right, do number 7, please. Number 7 can be tricky. You need to convert millimolar to molar. Millimolar.
Every time I start feeling confident, you give me a
You won't have a millimolar on the test. But it's just like going from milliliter to liter. Okay? Yes. Oh, you guys, we're losing it. We have 8 minutes left. Ugh. Either pho or ramen. Or sizzling rice soup. Is it like ready to turn in pretty much? Everything glued in? Okay, then yeah, you can leave it here. That's fine. There's actually one right under Ethan's feet. So, we'll take your notes home, but you can leave your lab notebook here. I'm gonna do 16 by hand and I will put it on Remind. All right, I'm tired, so here's the answer. If you're not ready to look at it, don't look at it.
So how does Remind work?
Lorena will send you a message whenever she posts them.
I know, but like I didn't like sign up for it until like actually
Okay,
like
so text, start a new, oh wait. You're already in it.
I
Go to your text message. Now text to, don't search. Because it's not you. Do a new message. 81010. And then you're gonna
Oh, I got it.
put at Biotech 212. Yeah. Yeah. Oh, no. That's what, that's wrong. Take that out. You just want 81010. Now in your message, do add. No, cancel. Sorry. Yeah, in your message, do this. You guys, I still have something to show you. So sit down.
So am I in it now?
Just respond. Okay. I'm gonna show you what we're gonna do today. Shh. So I have this review. I'm gonna post it. Oh, I'll just wait. Oh wait. That's not over yet. This is what I will post. It doesn't have answers to it yet, and I probably will not put answers for every single slide. I'll try to get as many as make sense. But this is things you need to review, like name as many safety rules as you can think of. You have a couple of questions on safety rules. Okay. What the process of science. So guys, if you go in your notes, page 1 was safety rules. Okay, you could review that. Page number 2, process of science. You have this. Okay, so this just is saying, what should you know? What are the parts? Is it linear or cyclical? Do people do it by themselves? Or is it collaborative? What is going on? You have a test. You guys are just complaining to me that this is hard, but you don't listen when I try to teach you. It's not just lecture. Okay, IVDVCV. This is one I'll probably put answers on. So you can look at the question on the next slide. I'll have the answers you can review. Okay, 8 parts of a scientific paper and what is included. That I probably won't put the answer because you have it in your notes, page 4. Just read your notes. Okay. Define theory. Again, you have that in your notes. So all of this stuff comes straight from your notes packet. If you're missing a page of the notes packet, go to the presentation. Protocol for using a microscope. These are the things I need you to know about it. All written in your notes. Protocol for using an analytical scale, specifically including a weigh boat. So you guys all use the weigh boat. So do you know how to use a scale? Okay. A hot plate. What is this? Basically the safety around a hot plate. Protocol for a micropipette. Make sure you're switching your tips, right? Make sure you don't put it upside down. All written in your notes. Microcentrifuge, specifically balancing. You want to make sure you can recognize if it's balanced or not balanced. Incubator. We have a couple rules on how to use an incubator, all in your notes. I did. Shh. 5 different tools that can be used to measure volume. You have that in your notes. Beakers, flasks, graduated cylinder. Which of them is least accurate? Can you read this volume? 4 types of micropipettes. What's the max volume for each one? You're going to have a question like this. We're going to say for a P1000, you want to set it at 250 microliters. What are the numbers? Okay, so make sure you go that. It's not done yet. I'll continue adding review questions and I'll go through and put answers and I'll send you reminds. So I will end the class today with one more time the remind code.